be learning about compound interest. So what is compound interest and why should we learn a little bit about it? If you invest money in a building society or a bank savings account, the building society or bank pays you an interest. So if you put money in, you'll get some sort of money in return. If you borrow money, you pay interest to the bank. So if you're asking to borrow money, you're going to have to pay a little bit more in excess, and the interest is worked out as a percentage of the amount you lend or borrow. So a couple of key words. Interest. So you earn interest when you invest in a savings account at a bank. However, you pay interest if you borrow money for a mortgage, for example, or for a car. Principal, so it's the original sum you invest, is called the principal. So the original amount is called the principal, and compound interest, it is the added to the principal and will itself earn interest. So it's basically you earn interest after every new amount that's added in. So if you invest £100 and you get at the end of the year £120, the new interest will be on the £120, not on the original money. So that's what compound interest means. You get interest on the interest. Okay, so here's an example of how you would calculate it step by step. So calculate the interest when £400 is invested for 3 years at 5%. So you've got 5% compound interest. So the first year, you do 5% of 400, which is £20, and you'd add it on, giving you your first year, you end up with £420. For your second year, you do 5% of 420, because that's already in the account. So 5% of 420 is £21. You would then add that on to 420, and that becomes your new principal, so your new amount of £441. And finally, because it's asked you for the 3 years, your third year, you'd find 5%, 441, which would be £22 and 5 pence. And then your new principal, your new amount, will be £463 and 5 pence because you've added it on. So this is how you do it step by step with compound interest. However, there is a formula which we're going to learn how to use so that you don't have to do each year one at a time. And that's the following. So to calculate compound interest, we can use the following formula. Our new amount, which is obviously how much we're going to get in return in total, equals the principal. Remember, the principal is the original amount that you invest, multiplied by the multiplier. Okay, so multiplier we should remember when we did a percentage of increase and decrease with a calculator of percentages, and then n is the value of years, so how many years or how much time you're investing for. So let's have a look at some examples. So £1,500 is invested at 3.5% compound interest over 7 years. So it's a 3.5% increase as a multiplier. Remember, we add, if it's increased, we add it to 100 and divide it by 100, which gives us a multiplier of 1.035. The principal after 7 years, it's 1,500 multiplied by your multiplier. Remember, the multiplier we just found out, to the power of your time. In this case, it's 7 years. So to the power of 7. And then you'd find out your answer. But remember, we're talking about money, so we're going to round it to 2 decimal places, giving you £1,908 and 42 pence. Let's have a look at the next example. So £340 is invested at 6.5% compound interest over 12 years. So first thing you have to do is find your multiplier. It's an increase, so you're going to add it to 100 and divide it by 100 to find your multiplier of 1.065. You then know that your principal after 12 years is going to be 340 multiplied by your multiplier to the power of your years, so 12 years, okay? And that will give you a value of £723.98272221, but remember we're talking about money, so we have to round it to 2 decimal places, giving us a final value of £723.89. Okay, these two examples I'd like you to copy down. So if you put £500 in a bank for 4 years and were paid 3% interest per year, how much would you have? Okay, so the exact same concept. You find your multiplier, so it's 3% increase, so you're going to add it to 100, divide it by 3. You end up with a multiplier of 1.03. Your principal then, after 4 years, because that's how long it's asked you to invest for. So 4 years there. So, and the original amount, or your principal amount, is 500. So 500 multiplied by your 1.03 to the power of the amount of time, your years, which is 4. so your 4 comes from there, equals 562.754405. Talking about money, so rounded to 2 decimal places, we end up with £562.75. Next example, remember to copy these two down. If you put £100 in the bank for 24 years and were paid 4% interest per year, how much interest would you earn? So this one's slightly different. It's asking you sort of the difference. How much interest would you earn? So same thing. First thing, you find your multiplier. 4%, you're increasing, adding it to 100, divide by 100 gives you a multiplier of 1.04. Your principal after 24 years, so your principal amount is £100 and your time is 24. So it would be 100 multiplied by 1.04 to the power of 24, and that gives you £256.3304165. Rounded to 2 decimal places is £256.33. But the question itself asks you how much interest would you earn. So now you'd have to find the difference between your principal amount, how much you put in originally, and how much you've come out with. So you do what your total is, which is 256.33, subtract your principal amount, which was 100, and you end up with your interest earned over 24 years with 4% interest of, of £156.33. So pause this if you need to catch up to copy it down. Okay, moving on. I'd like to pause this video and have a go at these 4 questions. Okay, so the answers to the following questions. So for question 1, you should end up with an answer of £2,105.75. Supposed to be a 0. Question 2 would have been £4,410. Question 3, the value of the house would appreciate to a value of £124,229.69. And then question 4, how much interest does she earn? So the difference would have been £100.41. So £100.41. Okay, moving on. So depreciation. Depreciation is basically the opposite of compound interest. So compound interest usually refers to an increase of something, and depreciation is obviously decrease. So to calculate depreciation, we use the same formula as compound interest. There's only one small difference. Okay, the difference is your multiplier. Now we all know that when we're increasing by a percentage, we add to 100. Therefore, the difference when we're depreciating, we are reducing. We're going to subtract from 100 rather than add. Okay, so let's have a look at 2 examples. Please make sure that you copy down these 2 examples into your books. So a car loses 12% of its value each year. What is the worth after 7 years if it costs £12,000 when new? So same thing, you find your multiplier. Oh, so it's not supposed to say increase. It's supposed to say decrease. 12% decrease as a multiplier, so you're going to do 100 subtract 12 divided by 100, which gives you a multiplier of 0.88. A principal after 7 years, so your principal amount was 12,000, your amount of years is 7, your time, so it would be 12,000 times by 0.88 to the power of 7, which gives you a value of 4,904.107156. Talking about money, rounded to 2 decimal places, we end up with a value of £4,904.11. Next one, the polar ice cap in the Arctic is 4 meters thick. If the ice is thinning at a rate of 6% per year, how thick will the ice be after 5 years or in 5 years' time? So that's your time, that's your principal amount, 4 meters, and that is your a percentage that's going to be depreciating by. So again, I believe that's supposed to say decrease. So 6% decrease as a multiplier. You subtract it from 100, divide it by 100, you end up with 0.94. So your principal after 5 years, remember your principal is 4 meters, so it's 4 times by 0.94 to the power of 5, which gives you a value of 2.93561609. We're going to round it to 2 decimal places, so we end up with 2.94 meters. So that's how thick your ice is going to be in the Arctic after 5 years if it was originally 4 meters thick. So pause this video if you need to copy these two down. Okay, so there's two questions. If you could please pause this video and have a go at these two questions. Okay, I'm going to pop the answers. So for question 1, it should hopefully end up with a value of 8,698 people. And then for question 2, it was £4,533.42. One final thing, so calculate the number of years in compound interest. So we already know what it is to what the formula is to calculate compound interest. So it's your new amount is equal to the principal, or your original amount, times by your multiplier to the power of n, and n is the amount of years. However, what if you're given a question where you do not know what the number of years is? So we have an example here. Josh invests £500 for n years in a savings account. He was paid 4% per annum, compound interest. At the end of n years, he had £740.12 in the savings account. Work out the value of n. So what this means is that you're not given your little n value. You're not given this value here, but you are given everything else. So we know that our new amount, so I'm going to put NA, is going to have to be equal to £740.12. Okay, so if we input the information here into our formula, we know our principal amount is £500. Okay, and then we're multiplying by our multiplier. Our multiplier is going to be so your multiplier is equal to 100 plus 4 divided by 100, which gives you a value of 1.04. So our multiplier will be 1.04 to the power of n, because we don't know, and that's going to have to equal to this value. Now, when we are doing this, all we have to do here is an estimate, so we guess. So let's guess. Let's put a value for n. So if I'm going to guess, so my first attempt, so attempt number 1, I'm going to do 500 times by 1.04 to the power of, let's say, 6. And let's have a look at what value we get. So 500 times by 1.04 to the power of 6, we get a value of 600. We get a value of £632.66. So this is still too small, so that means that this number here, your number of years, has to increase. So let's have a look at another one. So let's do 500 times by 1.04 to the power of, let's say, 8. So when we do that, we'll get a value of £684.28. So this value is still too small. Remember, we have to get to a value that's close to 740.12. So let's try another one. So let's go with 500 times by 1.04 to the power of 10. And when we calculate that to the power of 10, we end up with a value of 740.12214. And then obviously this rounded to 2 decimal places is 740.12. And now we have figured out, so the value of n is equal to 10 years. So when you're asked to find n, what you have to do is use your formula and then have a guess, have a trial and error until you get to your rounded amount. Please make sure that you've copied this down into your books and pause the video if you need to.